One of the most ambitious space missions ever is just about to launch. It's called the Gaia satellite, and it's due to map the precise positions of more than 1 billion stars. The ultimate aim to produce a 3D map of the Milky Way. Well, with us now, our science correspondent Palav Ghosh. Palav, tell us more.
Well, in just over 2 minutes' time, we're going to see what's been described as possibly the most ambitious space project ever take off from French Guiana. Now, this spacecraft, there's nothing been like it. It's going to map the position and the movement and the size of 1 billion stars in our galaxy. Now, all those pictures that you might have seen about the Milky Way, that's just a kind of estimate of what our galaxy is really like, because it's based on the movement and precise observations of just a few hundred stars. Now, for the first time, when this telescope has gathered its measurements, we'll find out what our galaxy is really like and perhaps discover all kinds of things that have never been seen before.
And it's going to sit in a location 1.5 million kilometres from Earth.
That's right. So it's got a bit of a journey to go. It's going so far from the Earth so that the Earth doesn't obscure its view. And then it's going to spend, once it's got to this position, 1 million miles from Earth, it's going to work for 5 years studying the galaxy and, as I say, get some of the most detailed observations we've ever seen.
And there's big British involvement in this.
That's right. Now, what you're seeing here is the most powerful camera ever built. They look like jewels, don't they? And they're able to take pictures of a human hair that's 1,000 miles away. That's
you are kidding.
That's true.
A human hair?
A human hair 1,000 miles away it'll be able to pick up. Now, it's got to be so powerful because the stars that it's going to be taking pictures of are 1 trillion miles away. So you need some kind of camera. So a British company's built the camera that sits at the heart of the Gaia telescope.
Well, what are we watching now? We're on the live shots now, so Palav, talk us down.
Now, we're at Mission Control in French Guiana. That's where the launch is taking place. It's actually a Russian launch operation, and that's a Soviet Soyuz spacecraft that's being used. Now, it's been specially adapted so in order to take the spacecraft 1 million miles from Earth. Now, that's not normal. Usually, it's just a few miles from Earth, or a few 100,000. So it's a souped-up Soyuz craft. It's now on the gantry. It's got one shot. There's no launch window. At 12 minutes past 9 and 19 seconds, it's either going to go up or they're going to scrub the launch.
Just looking at the count now, we're getting very close, aren't we?
That's right.
Should we have a listen in?
It's going. À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top, décollage.
It's so wonderful.
Situational French there as well. It's Decollage, takeoff.
Yes. So it's now on its way. It looks beautiful. I've been to French Guiana for one of these night launches. Night turns to day just for a moment, and then it's on its way. And in about 1.5 minutes, the booster rockets are about to separate, and then it'll be sent into space. Now, it's a relatively straightforward mission, but there is a kind of crucial phase in about 2 hours' time when the spacecraft will be on its way and it's got to unfurl its solar panels. Now, that's a tricky operation. It's being done by 19 little rockets. Now, if that fails to happen, then the telescope's view will be obscured. So, fingers crossed that that happens going to plan.
And will they know that immediately?
Well, it'll take a few minutes for them to work out, but more or less just after noon, we should know whether that crucial part of the mission was successful. Then on its way for the next month to take up its position, to scan the skies as it's never been scanned before.
And interestingly, it's a state-of-the-art processing centre in Cambridge, which is going to sift and digest all this massive amount of raw data coming in.
That's right. It's got intense computing power, and also the Institute of Astronomy is one of the leading centres for this kind of work.
It's an amazing story, isn't it, Paolo? We have to leave it there because we've got to get back to the rest of the news, but come back later in the morning and tell us how it's going.
Sure.
The